to heat it up 70 degrees Celsius to make hot cocoa. How much water, I'm sorry, how much heat is needed? It gives you the latent heat of fusion for water. It gives you specific heat of liquid water. Okay, so you've got 1.5 kilograms of snow. So this is one. You've got the mass is 1.50 kilograms of snow. What else do you have? You know the fusion, latent heat of fusion of water, which is 3.34 e to the fifth joules per kilogram degrees. That's it. Joules per, because it's not changing degrees. It makes sense. And then the specific heat of water, liquid water. Liquid water. You notice it's weird that you have to use liquid water now, just not just water, because the specific heat changes if it's solid or liquid or gas. It's kind of weird. Okay. Here it is. Joules per kilogram per degree Celsius. Fantastic. And we know what else? We know that it's going from 0 degrees Celsius. The change in temperature is 70 minus 0, which equals 70 degrees Celsius. Fantastic. So we want to know how much heat is needed to do this. Okay, so we know that it is snow, so it's a solid. We've got a solid going from solid to liquid. And it's a solid right at 0 degrees. So it's not changing any temperature at 0 degrees. So it's at 0 degrees, it goes from solid to a liquid. Then from liquid, it heats up the temperature. So we can kind of make a little story out of this. First, this is the first step. This happens, a phase transition, phase change. Second step, temperature change. And we know that there's going to be heat added to make this happen, and we know there's going to be heat added to make that happen. So the heat added when this happens, the first step right here, from a solid to a liquid, will involve this equation. And the temperature change here will involve this equation. And you need to add both of these heats up to get to the total amount of heat that's been added. So eventually these are going to be added together. So we know what the mass is. We know what the mass is here. The mass stays the same. We know what this is, it's given to us, and we know what this is, it's given to us, and we know what this is, it's given to us. So it just turns into this very easy problem where we add all of these values. We multiply these first, and then we add them to these multiply values. So we should get as a grand total, all of these Q's added together, the total amount of heat added to the snow to get it to this temperature of water is 940,000 joules. If you want to use kilojoules, knock yourself out. Okay, that's number one. Number two, how much heat is absorbed by 100 grams of ice at negative 20 degrees to turn it into water that at completely 0 degrees Celsius? So let's use a different color here. Let's use asparagus. All right, number two. Right, so we know the mass. Let's change the mass. Let's change the mass into kilograms. So the mass is 100 grams, so that's 0.1. Oh, we got 4 sig figs. Okay, 0.100 kilograms. Great. What else? We know the heat, latent heat of fusion for water. It's the same as the previous question. Joules per kilogram. And we know the specific heat of solid water, which is ice. So this would be the solid water. And that is 2100 joules per kilogram degree Kelvin. I want to compare these two numbers, this number right here and this number right here. Which one, it's just a question off the top of my head, which one of these requires, or does ice or does water require more energy to change it, to change its temperature? Does water or ice require more energy? You look at these two numbers. This one's bigger, so that must mean it requires more joules per kilogram to raise it a degree Celsius than this one. So it's easier to heat ice and change its temperature than it is to heat water and change its temperature. Water is pretty tough to change its temperature. It's a really good, as we say, insulator. It's hard to change the temperature of water. It takes lots of energy to do so. Okay. Back to the problem. The problem now, you've got -20, the change in temperature, -20 to 0. So the delta T here is going to be the final 0 minus -20 degrees Celsius. So that's going to be 20 degrees Celsius. It's raised 20 degrees Celsius. Great. So we've got two steps here. Again, we've got first a temperature change. The solid is going from a very, very low temperature to 0 degrees, and then we've got a phase change. It completely changes phase. A phase change. So for temperature change, we use MCAT, and for phase change, we use ml. So temperature change, here's the Q here. It's going to be MCAT, and here it's going to be ML, and that's going to be fusion. We'll use that one right there. Again, we know all of our terms. We know the mass. We know the C for solid water. We know the delta T, it's 20. We know LF, it's given to us here. So if we multiply these terms and we add these two together, just like we did before, you'll get this number, 38000 joules. That's the heat added. And that's the end of our problems. So good luck with the rest of the problems, and I'll be here if you have any questions.